Okay, now we need to write a rule for the nth term using the general rule. So we have the given value. The first term is 6, a sub 1, and the common difference is 2. So using the general rule, a sub n is equal, substitute the given values, a sub 1 which is 6 plus n minus 1, quantity of n minus 1 times the value of the common difference which is 2. Okay, so now let's proceed. Simplify the given equation. Substitute, distribute 2 to each term inside the quantity. So we have 2 times n, 2n, and 2 times negative 1 is negative 2. So a sub n is equal to 6 plus 2n minus 2. By simplifying it further, 6 minus 2 is 4. So we have a sub n equals 2n plus 4. This is now our rule for the nth term using the general rule. Number 1. Okay, another example. Write a rule for the nth term of each sequence, then find a sub 25 or the 25th term. Number 1. We have 48, 53, 58, and 63. So we need first to write the rule for the nth term before we find the a sub 25 or the 25th term. So a sub n is equal to a sub 1 plus quantity of n minus 1 times d. So substitute the value of a sub 1 and the value of the common difference in order for us to write the rule for the nth term for this sequence. So what is a sub 1? A sub 1 is 48 and the common difference is 5. So simplify it further, we have a sub n is equal to 5n plus 43. So how did we get 5n plus 43? Again, the common difference 5, distribute it to each term inside the quantity. So 5 times n is 5n, 5 times negative 1 is negative 5, and 48 plus negative 5 is positive 43. So the rule for the nth term for this sequence is a sub n equals 5n plus 43. And next is find the value of the 25th term or a sub 25. A sub 25 is equal to, substitute the value of n. A sub 25 is equal to 5 times 25 plus 43 is equal to 168. Number 2, we have a sequence negative 21, negative 39, negative 57, negative 75, and so on. Again, write first the rule for the nth term for each of this sequence. So substitute the value of a sub 1 and the value of the common difference. So what is the value of the first term? The first term is negative 21. And what is the value of the common difference? Negative 18. How did we get the value of negative 18? Okay, so that is by subtracting a sub 2, which is negative 39, minus a sub 1, which is negative 21. And that is negative 18. So simplify it further. We have now a sub n is equal to negative 18n minus 3. So how did we get negative 18n minus 3? Okay, that is by first distribute negative 18 to each term in the quantity. So negative 18 times n is negative 18n. Negative 18 times negative 1 is positive 18. And negative 21 plus positive 18 is negative 3. So the rule for the nth term for this particular sequence is a sub n equals negative 18n minus 3. So to find the 25th term for this sequence, substitute the value of n. So we have a sub 25 is equal to negative 18 times 25 minus 3 is equal to negative 453. Okay, another example, write a rule for the nth term for this particular sequence. A sub 17 is equal to 22 and d is equal to negative 4. So what we do not have here is the value of the first term. We have the value of n, which is 17. 17 is the value of n, the subscript of a sub 17. So we have 17 terms all. Okay? Then, so in order for us to find the value of the first term, we are going to use the general rule. Okay? So, substitute the given values. For a sub n, we are going to use a sub 17. So, we have now a sub 17 is equal to a sub 1 plus the quantity of 17 minus 1. 17 is the value of n times negative 4, which is the value of the common difference. So simplify it further, we have 22, which is the value of a sub 17, is equal to a sub 1 minus 64. So how did we get negative 64? Okay, so negative 64 is from 17 minus 1, which is 16, times negative 4, so that is negative 64. So simplify it further to find the value of the first term. Okay, we are going to use the addition property. So add positive 64 to both sides of the equation. So that is a sub 1 equals 86. A sub 1 minus 64 plus 64 is a sub 1. And 22 plus 64 is 86. So we have now the value of the first term. So since we have the value of the first term, we can now write the rule for the nth term. So substitute, using the general rule again, substitute the given values. A sub n equals the value of the first term, which is 86, plus quantity of n minus 1 times the value of the common difference, which is negative 4. So simplify it further, distribute negative 4 to each term in the quantity. Okay, so that is a sub n equals negative 4n plus 90. So how did we get this negative 4n plus 90? So that is negative 4 times n, which is negative 4n, and negative 4 times negative 1 is positive 4. So 86 plus positive 4 is 90. So the rule for the nth term for this particular sequence is a sub n equals negative 4n plus 90. Another example, write a rule for the nth term for this particular sequence. So we have a sub 15 equals 10 and a sub 20 equals 25. So what we do not have here is the value of the common difference in the first term. So to find the common difference, d is equal to the value of a sub 20, which is 25, minus the value of a sub 15, which is 10, all over the subscript of a sub 20, which is 20, minus the subscript of a sub 15, which is 15. So 25 minus 10 is 15, and 20 minus 15 is 5. So 15 divided by 5 is 3. So the common difference is 3. Now, since we have the common difference, we are going now to find the first term, or a sub 1. So using the general rule, we have a sub n equals a sub 1 plus the quantity of n minus 1 times d. Substitute the given values. We have a sub n, in which we are going to use a sub 15 is equal to a sub 1 plus the quantity of 15, which is the value of n, minus 1 times 3, which is the common difference. So simplify it further, we have 15 minus 1 is equal to 14 times 3 is equal to 42. and substitute the value of a sub 15, which is 10. So 10 is equal to a sub 1 plus 42. Then simplify it further. Using the addition property, add negative 42 to both sides of the equation. So that is a sub 1 is equal to negative 32 because 42 plus negative 32 is 0. So therefore, only a sub 1 will remain here. And 10 plus negative 42 is negative 32. So the value of a sub 1 is negative 32. Now, we have the value of a sub 1 and the difference, the common difference. So using the general rule, we can now write a rule for the nth term for this particular sequence. So using the general rule, substitute the value of a sub 1, which is negative 32, and substitute the value of d, which is 3. So a sub n is equal to negative 32 plus the quantity of n minus 1 times 3. To simplify it further, so we have a sub n equals 3n minus 35. So how did we get this? So first, we are going to distribute 3 to each term inside the quantity. So 3 times n is 3n. 3 times negative 1 is negative 3. Negative 32 plus negative 3 is negative 35. So the rule for the nth term for this particular sequence is a sub n equals 3n minus 35. Another example. So we need to write a rule for the nth term for this particular sequence. So again, there is no common difference and there is no first term or a sub 1. So we need to find first the common difference. So just like what we did from the previous example, so to find the common difference, subtract the value of a sub 27, which is 37, minus the value of a sub 12, which is negative 23. So 37 minus negative 23 all over the value of the subscript of a sub 27, which is 27, minus the value of the subscript of a sub 12, which is 12. And that is equal to, so 37 minus negative 23 is equal to 60, right? And 27 minus 12 is equal to 15. So 60 divided by 15 is equal to positive 4. So we have now the value of the common difference, which is positive 4. Now, to find the value of a sub 1 or the first term, so we use again the general rule. So substitute the given values. We can use, for a sub n, we can use either a sub 12 or a sub 27. So here in the given example, we use the value of a sub 12. So we have now a sub 12, which is negative 23, is equal to a sub 1 plus 44. So how did we get 44? So that is by 12, quantity of 12 minus 1 times 4. Okay, what is 12? 12 is the value of n. The value of the subscript of a sub 12, yeah, is 12. So that is the value of n. Quantity of 12 minus 1 times the quantity of, quantity of 12 minus 1 times the common difference, which is 4. And that is equal to 44. 12 minus 1 is 11. Times 4 is 44. So we have now negative 23 equals a sub 1 plus 44. So to find the value of a sub 1, we use again the addition property by adding negative 44 to both sides of the equation. So 44 plus negative 44 is 0. So therefore, only a sub 1 will remain in the right side of the equal sign. And 44 plus negative 23 is equal to negative 67. So negative 44 plus negative 23 is negative 67. So we have now the value of a sub 1 or the first term. So to write a rule for the nth term in this particular sequence, use the general rule again and substitute all the given values. So a sub n is equal to negative 67 plus the quantity of n minus 1 times 4. So simplify it further, we have a sub n equals 4n minus 71. So how did we get this 4n minus 71? So first, distribute 4 to each term in the quantity. So multiply 4 to each term in the quantity using the distributive property. So 4 times n is 4n, and 4 times negative 1 is negative 4. Negative 4 plus negative 67 is negative 71. So we have now the rule for the nth term for this particular sequence. A sub n equals 4n minus 71. Next,